Hello, this is part 3 of the basic astronomy quiz. I have links up here to the first part and the second part if you haven't watched those. Also a link to an entire astronomy course if you want to refer to that. And I'm calling this series, this three-part series in the basic astronomy quiz, simple things that you may be embarrassed to admit you do not know, because most of the things I'm asking about are very simple and you would think most of us would know it. Although in this quiz, after about half a dozen questions, we'll get into some questions that really are not so obvious and that not everybody we would think would know the answers to. But we're going to start very, very simple and build up to some things that are less obvious. First question, I think we're up to question number 28 if we're following the sequence of numbers from the first two parts of this quiz. From the point of view of being in outer space, from the point of view of being in outer space, all planets travel in the same direction around the sun. So if you're looking down on the solar system, are all the planets revolving around the sun in the same direction? Of course that's true. And if that's not obvious to you, or if you want to learn some additional things about planetary orbits, I have a link to another tutorial video that explains terms like the inclination of the orbit, the eccentricity of the orbit, things like what the main asteroid belt and the Kuiper belt are, and other details about planetary motion in our solar system. Okay, next question. The order of the planets from the sun is as follows: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. Is that the order of the planets? Yes. Pluto is sometimes considered to be a dwarf planet rather than a planet, so it's debatable whether you should include Pluto in that list. And why Pluto is often regarded as a dwarf planet is also discussed in that same video that I have a link to on the previous slide. Okay, next question. The farther from the sun a planet is, the longer it takes to revolve around the sun. Is that true? You should know the answer to this. Yeah, that's true. Next question, very simple. The Earth takes about 365.25 days to revolve around the sun. Mercury and Venus take less time than this, and the planets Mars, Jupiter, Saturn, etc. take more time than the Earth takes to revolve around the sun. Is that true? Yes, it's true. That's basically what I just said. Planets closer to the Earth are revolving faster around the sun. Next question. It takes Uranus about 30 years to go around the sun. Do you have some idea of how long it takes planets to go around the sun? Is that true? No, that's false. It's actually Saturn that takes close to 30 years, about 29.5 years to go around the sun. And here are the times it takes the planets to go around the sun. Their revolutionary period is another way of stating it. Mercury, 0.24, in other words, close to 1/4. It's going about 4 times faster than the Earth is traveling around the sun. Venus, 0.62. Earth, of course, is 1 year. So this is the number of years it takes. Mars, 1.88, almost twice as slow as the Earth. Jupiter, 11.86, so almost 12 years to revolve around the sun. Saturn, 29.5 years on average. Uranus, 84 years. Neptune, almost 165 years. And Pluto, of course, would be even slower. So that gives you, some idea of how long it takes the planets to revolve around the sun. Now, slightly different topic. Seasons are important. I mean, if we don't know when spring is coming, we don't know when to get ready to plant, our gardens, etc. It's nice to know when the seasons will happen. We know it takes about 365.25 days, so you could start on a given day and count 365, and then every 4 days add a day. That's what we do with our calendars. But is there some other way to know when the seasons are going to begin rather than counting each day? Is there something you can look at in the sky that would tell you when the seasons begin? This was used by people in many cultures in ancient times. And a hint, Stonehenge and other sites help with determining the first day of spring by visually looking at something in the sky. What is it you can see in the sky that tells you what season it is? One thing that would tell you is where the sun rises, because the sun rises directly east on the first day of spring and the first day of autumn. And it also sets directly west on those days. So where the sun rises is also an indication of what the season is. Okay, Now here's an interesting question. Does the Earth we know the Earth is rotating, it's spinning around. It spins around every 24 hours, which creates day and night, as this Earth either faces the sun or faces away from it. Do you think of the spinning of the Earth as being similar to a spinning top? Is that a fair comparison? Yes. In fact, astronomers sometimes make that comparison. And if that comparison is good, can we go another step in that when a top spins, it wobbles. Is it true that the Earth also wobbles like a top? Is that true or false? And the answer is true, and I'll show you a picture of that at this website page at wikipedia.org. I've brought it up here, and this is a gyroscope, which is essentially the same as a top, spinning around. The gyroscope gives a good image of this because this horizontal thing here, this horizontal circle, is like the equator of the Earth. So this is very much what the Earth does, is it wobbles around like this. And in wobbling around, notice what happens to the North Pole. This point up here is like the North Pole, and it's making a circle. Can you see that? It's making a circle. And the equator is wobbling around and facing in all directions. So this horizontal circular band is analogous to the equator of the Earth. And notice how it's pointing down. Let's see if I can describe it. It's pointing down towards me, down to the left, up. You see that it's pointing down in all those different directions. Now the down is to the right, front, left, back, right, front, left, back, right. I'm talking about where it's spinning all the way around. This is going to be very important in astrology. I'm going to explain how this wobbling of the Earth is very important in the ideas of in astrology. How this wobbling actually occurs with our Earth. Sounds kind of scary, doesn't it? Our Earth is spinning and it's wobbling around like this as well. Okay, so this is true, and I'll explain more about this in a moment. Okay, so I wrote here, notice how the North Pole, quote, North Pole, and the, quote, equator of the gyroscope spin around too. So as the Earth wobbles, the North Pole goes in a circle, and the equator spins all the way around as well. This is what the Earth is doing. But let me say one more thing before I leave this slide. How long does it take the Earth to make one wobble? It takes the Earth one day to spin around, but the wobbling, that circular wobbling all the way around, takes almost 26,000 years. Let's look at this picture again. Oh, I've zoomed it in. I didn't mean to do that, but it's kind of handy. So here, this point up here, which we could imagine as the top of the Earth, the North Pole, is spinning around in a circle, and it takes almost 26,000 years for that to spin around, which means that the equator of the Earth is going to spin around as well over 26,000 years. It's amazing, might sound like science fiction, but it's true. That's what happens. Okay, and I'll talk more about this shortly. Now, but for a moment, let's jump to a different topic. Another topic. And I'm going to put all this together in a few minutes. This is all related to each other in a way, but let's jump around a little bit to a slightly different topic, and I'll pull all this together. Next question is, to describe a point on a line, one dimension is sufficient. So if you have a ruler, and your ruler is in centimeters, and you have 1 centimeter, 2 centimeters, so I would just specify a point on my ruler and say I want 6 centimeters. That would be, we could call that one dimension. To describe a point on the surface of a floor, suppose you have a floor tile that needs to be replaced. You could describe where that floor tile is in 2 dimensions, starting in one corner and measuring in a coordinate system, what we would call an X and Y coordinates, which I think you're all familiar with, to describe where that tile is. And suppose you want to describe where a bulb of a light that's hanging from the ceiling, some point within the room, then I could use 3 coordinates starting in one corner of the room to describe where that object is in the room. Is that true or false? That depending on whether we're on a line, or whether we're on a plane, like a floor or a ceiling, or whether we're in a box, like a room is a box, and if I want to describe a point in that box, I would use the 3 dimensions, measuring along 3 coordinates. Is that what we can do? Sure, that's exactly what we can do. Now, could we also describe where a planet is using these same 3 dimensions? How, its height, width, make like some kind of giant box and describe where the planets are as if they were in a room, in some gigantic room. And we would have what's called an X, Y, and Z coordinates to describe where the planets are. Is it true that astronomers do this for some calculations, but is generally not needed or used in astrology? That is true. There's something called rectangular coordinates. You probably, good chance you never heard of them before, but just as a kind of curiosity point of interest, you can do that with planets as well. The reason I'm mentioning this is because it's not the usual way that we describe where planets are. We want to describe where they are from our point of view. So when I describe where something is along a line, I use a ruler, and I just talk about how many centimeters or inches along the ruler I am. If I want to describe a point in a plane, like where a floor tile is, I use a 2-dimensional coordinate system. If I want to describe where something is in space, in 3-dimensional space, I use 3 coordinates. But in astronomy and also astrology, we want to talk about where objects are when we point to them from our point of view. And how do we do that? True or false, we would do it with these 4 steps. I'll tell you the answer is true. This is how we do it. You select a great circle. You know what a great circle is. It's a big circle with you in the middle. You find a starting point on the great circle, because a circle is a circle, it has no beginning or end. So you find some way to identify a starting point, and then once you have a circle, you decide which of 2 possible directions you will move in. You decide on which direction to count your 360 degrees, and then you can describe where an object is in the sky by its longitude along the great circle from 0 to 360 and its latitude position 0 to 90 north or south, above or below, north meaning above, south meaning below, that great circle. So that's how we describe where things are in the sky. In astronomy and in astrology, we look at the sky as being a sphere, as being a ball, and we're in the middle of the ball, and we point to where things are. Okay, and if this sounds a little bit abstract, the link that I have on the very beginning of this tutorial video to the course in astronomy, the very first lecture is called What is Declination? Describes the celestial sphere and gives an idea of what these coordinate systems are. But here's the conclusion. You don't have to jump to that right now, even if this is a little bit vague. Let me make this clear. You know how we describe where something is on your floor, if there's a missing tile with X and Y coordinates. You know how we can describe where something is within a box using X, Y, and Z coordinates. How do we describe where a planet or star is? This is how we do it. We pick out some kind of great circle. One obvious great circle is the horizon great circle. Pick some starting point, such as east, for example, or maybe north or south. Those would be, or west. Pick some starting point. Decide whether you're going to, if you start east, are you going to start east and head towards north and you're counting 0 to 360, or are you going to head the other way? And now you can describe where any object in the sky is as a measurement along that great circle from 0 to 360 and how far off the great circle the object is. Okay, so that's how we describe where planets are in astronomy and in astrology. So the answer to this question is true. That's how it's done. And what is a great circle? What did I just say a great circle is? A great circle is a circle in which we, here on Earth, are at the center of it. Now, you can make an infinite number of great circles. What great circle do astrologers usually use to describe where a planet or fixed star is? So to describe where something is, you have to have a great circle as your reference point. Got it? Very important point. To describe where an object is in the sky, we imagine the sky to be a sphere. So another way of saying this is to describe where an object is on the celestial sphere, we need to pick out a great circle. What great circle do astrologers typically use? Answer: the ecliptic plane, which is the apparent path of the sun. That's the great circle astrologers usually use. What great circle do astronomers usually use to describe where, for example, a newly discovered minor planet is in the sky? So when astronomers discover a new minor planet or an asteroid or a comet or something, or they're just talking about it in general, but this is a good example, they announce that this comet is in a certain place in the sky. How do they usually describe where it is? Not always, but typically. Very typically, they're going to describe it in relationship to the celestial equator. So astronomers tend to use a different great circle than astrologers use. The celestial equator is the equator of the Earth extended out into the sky. So they use that as a reference point. In a minute, I'll talk about why astrologers use one and astronomers use another one. But let me ask one more similar question. What other great circle is used particularly by sailors? So if you're out sailing in the ocean on a boat, there's another great circle that is used to describe where a planet or a fixed star is. And what is that? The horizon plane. So sailors often use the horizon plane. So 3 different great circles that are used by different people in different situations. Now, what are the advantages and disadvantages of these different circles? Why would you want to use the ecliptic plane? What's your advantage to using that? Why might you want to use the celestial equator? And why might you want to use the horizon plane? There's advantages and disadvantages to each of these. And so for practical reasons, different ones are used. Astrologers often use the ecliptic plane because astrologers are especially interested in the planets. Astrologers sometimes use fixed stars, but their greatest interest is where is Mercury, Venus, Mars, etc. And they're always near the ecliptic plane. They don't go very far away. So it's a simple thing to do. You know, if I'm describing how to get to my house from another location, I might describe what landmarks there are. If there's a certain store or a street light or whatever on the way, it's nearby. It's the obvious thing to use as a nearby reference point. So that's a good reason for using the ecliptic plane. So if that's true, why don't astronomers use it? The reason astronomers tend not to use the ecliptic plane is because the ecliptic plane is moving all over the sky. And it's hard to know where it is. It's difficult to know where the ecliptic plane is. And what do astronomers want to do? They want to get their telescopes out and point their telescope to the planet or to the comet or whatever it is. And it's very difficult, even for an astronomer, to know where the ecliptic plane is at any given time. And the celestial equator is easier. We know where the celestial equator is. For example, suppose you live at 30 north latitude. It depends on where you live. If you live at 30 north latitude, the celestial equator is going to come up 60 degrees above the horizon in the northern direction, and the celestial equator always goes directly east and directly west. So we know where the celestial equator is. So if the astronomer says, oh, we discovered this new minor planet, and measured along the celestial equator, it's at 40 degrees from some particular agreed upon starting point on the celestial equator, and it's 10 degrees north of that celestial equator, at least we know where our reference point is. We know where the great circle is that we're basing it on. So it's a little easier actually much easier to understand where I'm going to point my telescope to look at this thing than if I use the ecliptic plane, because the ecliptic plane is moving all over the place during the day. Now, what's the advantage to the horizon plane? Well, the horizon plane is the simplest and most direct. It's actually better than the celestial equator for describing where you should point your telescope to see an object, because it's in relationship to the horizon, and the horizon is obvious. So the horizon plane gives the clearest explanation of where an object is. So why don't astronomers announce the position of the comet or the minor planet in terms of the horizon plane, the coordinates related to the horizon plane? The reason is because it would be different for every location. And they sometimes do that. They will say, if you're in New York City, this is where it is. If you're in Rome, Italy, this is where it is. If you're in Sydney, Australia, this is where it is. That gets to be very tedious. And the position related to the celestial equator is not dependent on the place. Now, all these things have names. The measurement along the ecliptic plane is sometimes just called ecliptic longitude and latitude. Astrologers often call it zodiac longitude and latitude. The measurement along the celestial equator has an odd-sounding names. It's called the right ascension and declination. Very odd terms, but those are the terms used to describe where an object is along the celestial equator. And when you measure in reference to the horizon plane where an object is, when you describe where an object is in relationship to the horizon plane, it also has some odd terms. It's called the azimuth and the altitude. And the word altitude here has a very different meaning from when we say the altitude of a city is so many thousand feet. Altitude here means the distance above or below the horizon plane. So you can describe an object in relationship to any great circle, and these three great circles are the most common ones used in reference to the ecliptic plane, the celestial equator, and the horizon plane. And now you have an idea of why they're used and what the advantages and disadvantages of measuring and describing where planets are and other celestial objects are in relationship to these three different great circles. Okay, now, of particular interest to astrologers, what is zero Aries in the zodiac used in the West, the tropical zodiac? What is it? What is the Ascendant? And what is the midheaven or 10th house cluster? What are they as astronomical phenomena? What are they physically? What are they out there? Can you, in a few words, or a few sentences, describe what they are? Okay, here's the answer. Zero Aries, the beginning of the tropical zodiac, is where the ecliptic plane and the equatorial plane intersect. That's what it is. You have great circles will intersect at two opposite points, and those two opposite points define the zodiac. They define the beginning and the halfway point, the zero Aries and zero Libra points of the zodiac. So again, two great circles will intersect at opposite points. So great circles are a big, big deal in astrology. They're a big deal for describing where things are. But in astrology, they're given great importance, and especially the intersection of great circles. So that's what it is. It's a peculiar and odd and strange thing, I guess, but that's what it is. And the Ascendant is the intersection of the ecliptic plane and the horizon plane, and the midheaven is the intersection of the ecliptic plane and the meridian plane. So where the ecliptic plane intersects other great circles become powerful points. It's really a peculiar idea that these abstract great circles would have such great power, but that's the idea. Now, why would the intersection of great circles be so powerful and so important? What's up with that? What's the deal? Why would you have these great circles, and where they intersect creates a zodiac and the Ascendant and the midheaven and all this? Wild. What's the intuition behind that? We don't know. And very curious to me is that I don't hear astrologers ask the question very often. They just, that's was just handed down, and that's how it works, and they accept it. But I think about these things. I think, well, if that's true, why would that be important? So I will suggest to you a reason that the intersection of great circles might be so powerful is that you can think of the great circle as the entire celestial sphere condensed, the whole power of it condensed into two dimensions, the three-dimensional, the spherical reality all around us condenses down into a circle. This is sometimes called dimension reduction, and dimension reduction is very powerful, for example, in string theory. And string theory is an attempt to explain the nature of everything, and one of the ideas in string theory is that there are many dimensions, but they get curled up, and we experience only 3 dimensions of space and 1 dimension of time, but there are actually more dimensions in reality. So dimension reduction may be fundamental to the way the universe works, and roundness in 3 dimensions is a ball or a sphere, and then it can that roundness can collapse into a circle. So that may be, and may sound abstract, but dimension reduction is fundamental to some ideas on the basic nature of the universe, and it may have something to do with why they're important in astrology. Basically, people hardly ever ask the question. I ask the question, and I'm proposing also, just proposing one possible way of thinking about it. Also, what's interesting about the zodiac is that where the ecliptic plane and the celestial equator intersect is known as the vernal equinox, and the opposite point where they intersect is called the autumnal equinox, and that is where the sun is on the first day of spring and the first day of autumn. So these intersection points of the ecliptic plane and the celestial equator define the seasons. When the sun reaches those points, that's the beginning of spring and the beginning of autumn. So they have a connection to the seasons. Those particular great circles do. Now, different topic. The stars are in the sky during the day, but we do not see them because the light of the sun overpowers the light from the stars. Is that true or false? Now we're back to something simple again. Of course that's true. The stars are still there, we just don't see them because the sun is so bright. And but I'm mentioning that to lead to something that's not so obvious. The stars behind the sun, if we could see them on the first day of spring, or any other day of the season, but let's just use the first day of spring, are always the same. So, is that true or false? So, on the first day of spring, if you were Superman or Superwoman and you could see the stars behind the sun, on the first day of spring, would you see the same stars? Like the same constellation, the same configuration of stars? Would it be the same? False. It would not be the same. You might think it would be, but it isn't. And to get more specific about it, if your answer to the previous question is false, and it is, how can you describe what stars are behind the sun on the first day of spring 250 to 300 years from now, as compared to the first day of spring this year? So say 275 years or so from now, can you describe what stars are behind the sun on the first day of spring relative today? The answer is you can. And what is it? The stars behind the sun will have moved about 4 degrees, because the stars behind the sun on the first day of spring move about 1 degree every 72 years. So 72 times 4 is 288. That was my number between 250 and 300. So it's roughly 4 degrees. Let me say that again. The stars behind the sun on the first day of spring move about 1 degree every 72 years. Or in other words, the vernal equinox, because where the sun is on the first day of spring is just the vernal equinox. Simpler way of putting this, the vernal equinox moves through the stars 1 degree every 72 years. Now, why is that happening? Why is that happening? And what is it called? It's called the precession of the equinoxes, and it's caused by the spin of the wobble of the Earth. It's caused by the wobble of the Earth. Earlier, when I said that I showed you the gyroscope, which is just like the Earth spinning around and wobbling around, and that wobble takes 26,000 years. 26,000 divided by 12 is a little over 2,000 years. So it takes a little over 2,000 years for that wobble to go 30 degrees, and it's about 1 degree every 72 years. So it's the wobble of the Earth that causes this precession of the equinoxes, which is the movement of the vernal equinox through the stars, which is also the movement of the zodiac, because the vernal equinox, which is the intersection of the ecliptic plane and the celestial equator, is the beginning of the tropical zodiac, and it moves through the stars 1 degree every 72 years. And the tropical zodiac happens to be moving backwards through the constellations, as I said, 1 degree every 72 years, which is 30 degrees every little more than 2,000 years, and that's what causes the ages. The age of Aquarius, Aquarius, harmony and understanding. So all of this great Aquarius stuff is all about the vernal equinox moving into a new constellation, into a new group of stars. And so for 2,000 years the vernal equinox was in Pisces, and now it's moving into the constellation of Aquarius. Okay, so you see that this stuff is very fundamental and important. It has to do with the astrological ages and some other things. Now, if the vernal equinox is moving through the constellations, and it's moving through the constellations, when was the vernal equinox lined up perfectly with the constellations? Right now, the vernal equinox, which is the beginning of Aries, is in the constellation of Pisces, and not too far from now it will be in the constellation of Aquarius as it moves backwards through the constellations. When were they lined up perfectly? That would occur every 26,000 years, and the last time it happened was somewhere between the year 1 and the year 800, not that long ago. And a very rough approximation, you may give a broader range or a narrow range. It's very difficult to define when the vernal equinox lined up perfectly with the constellations. And why is it so difficult to describe this more clearly? It's difficult because the constellations are not 30 degrees in size. Some constellations are much smaller than 30 degrees, like Aries is a small constellation. Some constellations are much bigger, like Virgo. These constellations with the names Aries, Taurus, Gemini, sometimes there are gaps between them, they overlap. They're not nice, neat little packages of 30 degrees, so you can't define clearly where, if you want to create a zodiac based on constellations, it's very difficult to do because you have to figure out exactly where you're going to put them. And some people do use the zodiac based on the constellations, but they don't agree about where the zodiac signs are. That's called a sidereal zodiac. So in the sidereal zodiac, there is not agreement about where the constellations are. In the tropical zodiac, we know where it is because it's based on the vernal equinox, and we know where the vernal equinox is. But the sidereal zodiac puts the signs approximately where the constellations are, and there's no clear, straightforward way to do that. And the difference between a tropical zodiac and a sidereal zodiac, because there are these two zodiacs, the sidereal zodiac, again, is a zodiac that is almost the same as the constellations. We can't make it perfect because constellations vary in size. And the tropical zodiac and the sidereal zodiac move 1 degree every 72 years in relationship to each other, as I explained, because the constellational zodiac is based on the stars. The sidereal zodiac is based on the stars. And the difference between them is called the ayanamsha. And some people spell it ayanamsa and pronounce it ayanamsa. So you get two pronunciations and spellings. Ayanamsha or ayanamsa is the difference between the sidereal zodiac and the tropical zodiac. And do astrologers who use the sidereal zodiac agree about what the correct ayanamsha is? The answer is no. I just explained that because the idea is that the zodiac sign Aries would be the same as the constellation Aries, but the constellation Aries is less than 30 degrees, and you can't just match them up perfectly. So you have different ideas about where the sidereal zodiac is, which means that the distance from the tropical zodiac varies according to different astrologers. So in India, sidereal zodiac is very popular, and some people use what is called the Lahiri ayanamsha. There are many, many ayanamshas. Some people in the Western world use an ayanamsha called the Fagan-Bradley ayanamsha. They just don't agree exactly where the zodiac begins in the sidereal zodiac. There are many ayanamshas. Those are just two of them. So if two astrologers use different ayanamshas, if you have astrologers who use the sidereal zodiac and they don't agree about the ayanamsha, does it change the astrology chart? Yeah, it changes it. The distance between the planets is going to be the same, but one astrologer may say that your moon is at 5 degrees Taurus, the other will say it's at 8 degrees Taurus, another will say it's at 10 degrees Taurus. They're going to be off a little bit relative to each other. Okay. But the distances between the planets won't change. Now, I think this is my last question. Yes, it is. Do any astrologers ever use a division of the sky into a different number of zodiac signs than 12? Just a final curious question. What's this fixation on 12? Did anybody ever have a zodiac of 15 signs, or 20 signs, or 30 signs, or 5 signs? And if they did they call them zodiac signs, or do they call them something else? What do you think? Are there other zodiacs that have different... We have a sidereal zodiac and a tropical zodiac. Both agree there are 12 signs, but are there zodiacs that have another number of signs? Yes, in Vedic astrology, which is popular throughout India and sometimes used in other places as well, it's a very popular zodiac, has 27 signs. And they don't call it a zodiac, they call them nakshatras, but it's a zodiac. I mean, it's the same idea. You divide the circle into 27 pieces instead of 12, and each of these pieces of the sky, these 27 pieces, have different meaning. And nakshatras are very important in Vedic astrology. They're not some subtle esoteric thing. They're fundamental, very, very important. Some medieval systems of astrology had 28 divisions similar to zodiac signs, sometimes called lunar mansions. So, just to let you know that that's what they are. So now you have an idea of what, from these questions, what the zodiac signs are. Sidereal zodiac signs are a division of the stars in the sky. Not complete agreement about how to do it, but that's what it is. And the tropical zodiac is based on a rather abstract idea, which is it's based on the intersection of two great circles, but notice that that is consistent concept with the Ascendant and the midheaven, which are also the intersection of two great circles. And I think that astrologers haven't thought enough about this. What we're really saying is that the intersection of great circles creates starting points. And that begins to make a lot of sense when you think of fractal theory, when you think of string theory, and dimension reduction and so on. And I talk about that in other videos. Okay, that's the end of our third part of the astronomy quiz. Thank you very much for listening. God bless. Namaste.